All right, guys, welcome back. Today we're going to talk a little bit about Job 5 and the build out for Job 5. So remember, we've got our three different drawings here: floor plan, cable diagram, wiring diagram. Floor plan is our shopping list. So we got to get ourselves a blank, and a blank. We also need to remember that this symbol is a blank. Okay, good. So the switch is going to control the light. The home run is coming up from the bottom into the light. So this light eventually is going to have a lot of stuff going on inside that light box. All right, so let's take a look. Let's go shopping, get the items for this. We got our switch, light, outlet. So on the job sheet, it tells us what we got to get when we go shopping. And on our project board, we have our switch, our light, and our outlet. Okay, so we're going to start moving on to the next drawing that will give us the information, and that is the cable diagram. So the cable diagram is going to tell us the types of cables that we need. So from the light box, we're going to need a 14-2 off to our switch. So from the light box, 14-2 is going to go from the light box to the switch box. And then on the drawing again, the home run is also going to go into the light box as well. So the home run is going to have a cable going to the light box. That's two cables already into this light box. And then last but not least, from the light box, a 14-2 is going to go to our receptacle outlet. So yet another cable is going to come from that light box and go to our outlet. So we're going to have three, count them, 1, 2, 3 separate cables entering into that light box. So that's going to be a pretty busy box as far as splices go. But don't worry, once we get the cables in, we'll start looking at that wiring diagram to show us where the splices are going to happen. Okay, so bear with me. I'm going to start getting through the cables into the boxes. So I'm going to move all the devices out of the way for now. And I'm going to get my 3 separate pieces of cable, and I'm just going to enter everything into this box. I'm going to make use of my internal clamps and also an external clamp. All right, when we get to the more advanced stuff, they start talking about box fill, which is the amount of wires you're allowed to fit in one box. We have to keep note of that, but for this project, we are good. We have just the right amount of wires in the box. So 6 to 8 inches long. What is this tool called? Good, that's a cable ripper. Expose my conductors. Trim off that white plastic sheeting and the cable. Enter into the box. We're going to call this our home run cable. So this is not going to have to be a very long cable at all, because this will connect to the power supply. The second cable I'm going to use is going to connect to my switch box. So my 6 to 8 inches, same process. A lot of redundancy in our industry, but the more you do it, the faster you get at it. But you don't want to get to the point where you're rushing. You want to make sure you're doing everything to the highest quality you can. So these internal clamps, there's actually a spot for 2 different cables to enter. We can stack them. We can put 2 cables underneath one, but I like to separate them. All right, we leave that 1/4 inch of spacing there. Take my flathead screwdriver, tighten it up. Nice and snug. We don't want to over tighten these clamps. They are made out of steel. The copper wire is soft and malleable. We can cut through that copper and definitely cut through the insulation of that wire if we're not careful. All right, so the other end of this cable is going to head on off to our switch box. All right, so same story, 6 to 8 inches long. Cable ripping tool. In our industry, you might not see the cable ripping tool. Some people will get away with using an X-Acto blade. Some journeyman electricians will actually use their lines and pliers to score the outside edge of the cable itself and then remove it that way. But there's specific tools. They limit the amount of damage we could do to the cable, so we use the cable ripper in here. Okay, got my 6 to 8 there for my switch. And then last but not least, I've got that 3rd cable coming from this box, just like we said on the cable diagram. So now I'm going to install this last 14-2, which will give us 1, 2, 3 14-2s inside that light box. And for this one, I'm going to use that external clamp. Nice and fast. Remove, get that junky paper out of there. Lines and pliers. And same story, the external clamp has these 2 external screws, and they're going to snug up on the sheathing and allow to have a little bit of that white sheathing stick into the box. And that kind of proves to the inspector, that's right, everything that we do in our world, we have to file permits for. I should say most of the stuff we do. There is some small repair work you're allowed to do without filing for permits. But there are permits and then inspections after the submission of a permit. So everything we do needs to get looked at by somebody else to verify that we've done it as per code, which does act as a checks and balances system. So we know somebody's coming out to look at our work, so that kind of motivates us to make sure we're doing the highest quality work we can. So we don't have the inspector come to the job site, find something wrong, request that we change it, and then schedule another day to come back and fix the project, okay? So it's gonna take time, and time is money if you're doing this as a job. So I got a little extra here, which is fine. I'm just gonna tuck that in. So what we have here, a long 14-2. I just didn't wanna waste anything, but it's still going off to my receptacle outlet, okay? So now all of my cables are installed based off of my cable diagram. Boom, done. Everything is all laid out and ready to go. Now I can focus on my wiring diagram. Sometimes I'll even fold this paper over to remind me that this is the only thing I have concern with right now. And when we do the drawing, we've gone over this drawing multiple times before. What is the first thing we're going to do? So we've got hots, neutrals, and grounds. What do we want to draw first? And that's also going to be what we're going to wire first. Very good. Grounds first. So who gets grounded? Everybody gets grounded. So I'm going to do the grounding for every single electrical box on the project. So we start off with my switch box. I got 1 bare copper ground wire here, and I got my 1 screw for my switch. Simple enough. I just got to bend the hook and throw this guy on the switch. Remember, we've got multiple ways to bend hooks. I like to use the wire strippers, but you can get away with using multiple tools, lines and pliers, needle nose pliers. Just stay away from trying to use your fingers. I see a few students in class that were coming in doing this live, and they were trying to use their hands to manipulate the copper wire. It gets thicker, right? This is the thinnest wire you'll find in a residential house, so you have a real hard time trying to bend these wires with your fingertips. You're going to end up cutting or hurting yourself. So we try to use the tools to manipulate the wire as much as possible. All right, this box here, a lot of craziness going on. All right, if I look at the wiring diagram, okay, my grounds, everybody gets grounded, but I've got my 1, 2, 3 ground wires inside this box, and I still have that 1 little tiny ground screw right there. So I'm going to need to get a piece of scrap and splice on a 4th piece. That's right, 4 wires, a 4th piece of bare copper, and that's going to act as my tail, which is going to go off to that ground screw. Okay, so I got my 4 copper wires all lined up. I bend my L, grab my lines and pliers. What direction am I twisting my lines and pliers in, guys and girls? Good, clockwise. That was the wire nuts. They go on nice and tight clockwise as well. Sometimes you hear a little click when they get to the point where they're full. Bend a hook on this end, right? So I got 3 wires I've just converted into 1 wire, and that allows me to connect to that single ground screw inside of the box. And I leave those jumpers or those pigtails 6 to 8 inches long as well. Nice and snug. Goes around the screw clockwise, and this is good. Make sure that wire nut's tight. Okay. Just going to take these wires, get them bent, a little bit organized and out of the way. Good. Grounding is done in this box. That was most complicated. And then last but not least, the outlet is easy enough. I've got one ground wire, I've got one green screw. So all I got to do is bend a hook and install it on the device, just like we did with the switch. Clockwise, around. I hold with my 2 fingers so it doesn't go anywhere. I'm even pulling on that bare copper wire with my other fingers as well. Okay, a lot of dexterity in our industry. When I was an apprentice and they actually had tests for apprentices, they had square pegs and square holes, and they timed you to see how quick you could put 25 square pegs and 25 square holes. And that was actually a test for your dexterity, to see how quickly you can move your hands around. Okay, good. Grounds are done. Grounds are done. Grounds are done. Grounds are done. So everything has been grounded. All right, if we go back to the drawing now, just like when we were doing the drawing itself, we've completed the grounds. We're going to do what next? That's right, the neutrals. So anything coming off this neutral bar is what we're going to attack next here. So if I notice this drawing, I've got my neutral coming up. It splices onto a 3-wire splice. I've got this white wire, and that little tiny scrap piece of white wire, all happening inside of that light box. Okay, so the white wire coming from the home run. Got to find that white wire. That's this white wire right here. That's this guy. Splicing onto the white wire going off to the receptacle. That's this white wire right here. And then a scrap piece of white wire going off to the light itself. That makes 3. Mr. Morelli, you forgot this one. Hold on, guys. Let's check this out. The white wire going off to the switch, no, that is doing something completely different, okay? That's that switch loop that we'll talk about when we start doing the hots. So we do not grab on that white wire going off to the switch, so we're going to ignore this white wire that's going off to the switch for now. We're trusting the drawing. The drawing says 3 white wires get spliced together, so I'm going to grab the 3 white wires I have at my fingertips. I'm going to strip them, and then I'm going to splice them together. And that's a nice solid 3-wire splice. And the other end of that is going to connect to the light itself. And that will finish up the neutrals for the project. Always make sure you trim off the end before you put the wire nut on there. Make sure that wire nut sticks on there nice and tight. And we do not want to see any exposed copper underneath the wire nut. If we do, that might have the ability to come in contact with other wires or the metal boxes and wreak havoc on the project. Other end gets the hook, which will go to the light. Silver screw is neutral, and that gold color screw is hot. So we're done. Our neutrals are done. Oh, not done. Neutral goes off to my receptacle. 1 white wire, bang, right to my receptacle. That's easy enough. Strip the wire, then the hook. Silver screw is my neutral. The longer of the 2 eyes is my neutral side. The side that shares the ground screw is my neutral side. So there's a lot of ways to identify it. And even if you flip the device over, some of the newer devices have some writing on the back that tells you which side is the white and which side is the hot side. So it's pretty self-explanatory. Okay. Now my neutrals are done. We got the grounds done. We've got the neutrals done. And now we've got to deal with the hots. So the hot wire coming off my circuit breaker, I've got that black wire coming in from the home run. So the black wire coming in from the home run is this black wire right here. That's going to splice onto the black wire going off to my receptacle. That's these black wires right here. And then last but not least, it's splicing onto the white wire that is acting like a hot wire going off to the switch. Switch closes, brings power back to the light, okay? So let's refresh this one. Black from the circuit breaker splices onto the black going off to the receptacle, and the white going off to the switch. So I got my black, and my white. That's that weird splice because of my switch loop. A lot of students get that mistake. They start thinking, Mr. Rinaldi, you told us switches don't get neutrals. But remember, none of these wires are making contact with that neutral bar in the drawing. So these are not neutrals. Electricity is colorblind. We could build this entire project with white wire if we wanted to. It'll still work the way we want it to. But it's just confusing for the installer. So that's why they give us color coding with cable. But unfortunately, sometimes we have to cheat with that color coding because they do not make cable that custom where we can get 2 black wires and a bare copper in there, or 2 white wires and a bare copper in there. We can do that with conduit though. So if you have empty pipe or other mechanisms of running electrical wire, you can do that, but not in our world right now. White wire goes off to the switch. Does it matter what screw terminal on the switch we attach to? No. The only thing the switch is doing when we turn on this switch, the switch is making these 2 screw terminals have contact with each other or not contact with each other. So it does not matter which wire you bring to the switch. It's just making those wires touch or not touch. So white wire, black wire will both go to the switch. Switches don't get neutrals, Mr. Rinaldi. Remember, the other end of this white wire is not attached to that neutral bar. That's the end that we connected in that splice with the other 2 black wires in the light box. A little confusing, I know. Good news is the National Electrical Code no longer allows a switch loop to take place, so we cannot install these new in somebody's house. But unfortunately, lots of houses in our area have been built and been around for a long time. So this is one of the more common things you will find inside of a house. That's why we still teach it. Okay, so we got these 2, bang, done. Switch, done. Now, when the switch turns on, we follow that black wire, and that's the last wire left. This is the switched hot. When this switch turns on, this gets energized. When the switch turns off, this gets de-energized. So anything we want that switch to control is going to be attached to this black wire. On the drawing, the switch is only going to control the light. So when that switch turns on, it's only going to go off to the light. Then 1 hook on this thing, and that is all she wrote, folks. Job 5 in the bag. Gold color screw is my hot. Around the screw terminal. Tighten it up nice and snug. And I forgot the hot wire for my receptacle. Black, gold color screws. And now we're really done. Okay, now we are done. So when we fire this thing up and plug it into our power supply, the switch is going to control the light, and the receptacle outlet is always on. All right, thanks for joining. This was job number 5.